So my dear friends, let me come down to our fresh part D, that is irrational numbers. Now this irrational numbers, quite often students mistake it with a very difficult topic, but it is not. We have seen this topic in our previous standard. Now let me deal more things out of this irrational number, and irrational number with respect to this square root of x. Square root of x. I take two numbers, 4, 2. Try to understand. We know the definition of irrational number, but let me deal in a more creative manner. If I put this 4 inside this square root, it will come out to be 2. And what is the definition of rational number? P by Q. So this is 2, which is 2 by 1, which is equal to P by Q, where P and Q are integers. Therefore this is square root of 4 is nothing but a rational number, right? Now let me again check out with this number 2. If they put this 2, by the way, what is 2? 2 is a prime number, the only even prime number, a number divisible by itself and 1. So if I put this 2 in this square root, so this is square root of 2. So what is square root of 2? It is equal to P by Q? No, it is not equal to P by Q. That means it is not rational number. Therefore, it is a rational number. By the way, root 2 is what? 1.41 ... That means this is non-terminating, non-recurring, which is the definition which we have seen earlier. This is irrational number. So, what is the conclusion? Square root of prime number is equal to irrational number. Square root of 2. 2 is a prime number. Yes, therefore it is an irrational number. Square root of 3. 3 is a prime number. Yes, therefore it is irrational number. Square root of 4, as we have seen, no way, because this is 2 and 2 is not a, yes, irrational number, it is a rational number, right? 4 being not a prime number. Square root of 5. 5 is a prime number, therefore square root of 5 is a rational number. So let us come down to two theorems of part D. Theorem number 1.3, that is third theorem, and theorem number 1.4, that is the fourth theorem. Let's check out. Now my dear friends, let me study theorem 1.3, right? You know, quite often I get tired of reading theorems because that is so messy, you know, so troublesome for us to understand, right? So what we do, we read out the theorem in a very fun manner. So here goes the theorem. Let P be a prime number. Let P be a prime number. Full stop. If P divides a square. What did I say? If P divides a square, then P divides A. P divides A. What is A? Where A is a positive integer. Oh my God, this statement is so difficult to understand.
Oh no.
Yeah. So what shall I do? Let me simplify this statement. Oh my God, this theorem is bouncer. I'm unable to understand this theorem. This is bouncer for me. So what shall I do? Let me take this theorem in a very simple manner. Let me take out the elements from it. So what did the theorem state? The theorem states that let P be a prime number. So let me take P, which is equal to prime number. Give me one prime number. Oh, you want to take it 3? It is 3. Prime number is 3. And here again there is another letter, another variable A. So what is A? Rather constant. That is positive integer. Give me one positive integer. Oh, did I hear? You said 6. So therefore A is 6. Now let me give you this theorem in a very simple manner. So here we go. So we take one by one. If in a box, what is if? If matlab given. If means given. If P divides A square, that means A square upon P. What is a? 6. That is equal to 6 square upon 3. What is 6 square? 6 square is 36 upon 3. What is 36 upon 3? That is 12. Therefore, it satisfies. That is, a square gets divided by p, or p divides a square, right? Then p divides a. What is then? Then is this box that is to be proved. What is this box? A by p, which is equal to 6 by 3, which is equal to 2. That means it is true that if 6 square is getting divided by 3, then that 6 is getting divided by 3. This is what is the theorem is. So my dear friends, this is what is the theorem, and this is what is the theorem. Which one looks pretty simple? This one? So I don't think this statement would be remembered properly. So for memory, increasing your memory skills, let me put this theorem in a very simple manner. What I do, I put that if wala part, right, in a box. So box would say a square by p, that is p divides a square, implies another box, then wala part. So then that then wala part is nothing but a is divided by p. So a square by p in one bracket implies a by p in another bracket. This is a simple theorem, and the proof of this theorem goes here.